BCI is the next evolution. No wait, it's the new Big Bang in tech. Imagine if you could cook dinner while lying in bed, or just by thinking about it. Or what if you could manage your negative thoughts, dial down your pain, and even upgrade your brain power while you're still half asleep? With BCI, it's not science fiction anymore, it's happening. BCI stands for Brain-Computer Interface, or sometimes they call it BMI, or Brain-Machine Interface. In short, it's connecting your brain directly to a computer-based system. It's like plugging your brain into a system that can read your brainwaves, decode them, and make sense of those signals. Just like translating mysterious brain signals into actions like moving a wheelchair or calming your mind when you're anxious. Yeah, you might be thinking about Elon Musk's Neuralink project right now, and you'll be right. It's one example of BCI where someone can think about moving a wheelchair and boom, the wheels start turning. Or imagine it could notify you, hey, anxiety signals are flaring up in your brain, and help you chill out. How does it work? Let's break it down. First, how does the system actually get your thoughts and emotions? There are three main types of BCIs. 1. Invasive, 2. Partially, and 3. Non-invasive. In the invasive BCI, electrodes are surgically implanted directly into your brain, getting super close to the neurons. It's like planting a microphone right inside a room to catch every single sound. Super accurate, but yeah, as you guess, it's risky and mostly for paralyzed patients. One cool method is LFP, or local field potential. This measures electrical energy from small regions of the brain, or even more precision, there's spike recording, which captures super fast electrical signals from a single node. Fun fact, Elon Musk's #1 project uses methods like spike recording and LFP. The second one is partially invasive BCI. This is like using ECOG or electrocorticography. Electrodes are placed on the surface of your brain, but they don't dig it into. So you still need surgery, but it's a bit safer. The accuracy not as sharp as invasive, but better than non-invasive. And number 3, non-invasive BCI. You've probably heard of EEG, or electroencephalography. No surgery, just a cap on your head that picks up brain signals through your scalp. Less accurate, sure, and there's more noise, but it's perfect for gaming. Imagine controlling a video game just with your mind. No joystick needed. Fun, right? Oh, and some experts suggest combining methods like ECOG and EEG to get the best of both worlds. Processing brain signals. Once the brain waves are captured, they need to be processed and understood. First, we need powerful algorithms to amplify and categorize these signals. But brain signals are tiny and filled with noise from both inside and outside the body. So before we even get to the deep stuff, there's a stage called pre-processing, where we filter out all the noise, calibrate the system, and extract the cleanest signals possible. Now comes the cool part, deep learning. We can use neural networks like convolutional neural networks, or CNNs, and the recurrent neural networks, RNNs. Each have distinct roles. CNNs are highly effective for analyzing spatial data and EEG signals measured from the scalp, as they can detect local features and spatial patterns in brain signals. On the other hand, RNN are well suited for sequential data like time series brain signals as they are capable of capturing temporal dependencies in the data. In short, CNNs focus on spatial pattern recognition, while RNNs are used for modeling temporal pattern. Together, they allow the BCI to understand and predict what your brain wants to do. Neurofeedback, taking control of your brain. Now imagine you are getting real-time feedback from your brain. This is called neurofeedback. It could be the visual, like a graph, or even though a message telling what's going on in your mind. Caring for houseplants. Over time, you can learn control your brain's activity. For example, if your brain is firing up anxiety signals at a certain frequency, you'd get an alert. With practice, you could reduce it in real time, or you could turn down the parts of your brain responsible for fear or anger and turn up your focus and calmness. All this happens consciously. You're actively learning to control your own brain patterns. You are the one in charge, training your brain, boosting your memory, sharpening your focus, or even improving your creative or critical thinking. Cool, right? Medical marvels, ALS, paralysis, and stroke recovery. Now let's talk about real revolution. BSI could be a new big bang for patients with severe disabilities like ALS, paralysis, or even stroke survivors. Imagine a stroke patient learning to produce the right signals so their paralyzed muscle slowly reactivate. Imagine being able to perform the most delicate task with your prosthetic hand using minimal mental effort, from pouring a drink to picking up a delicate cup, or expressing your feelings to flowers, all just by thinking about moving it. Their brain sends a signal and boom, their prosthetic hand moves like it's part of their body. Chronic pain management. Chronic pain is a huge medical problem, but BCI is helping us to figure it out. BCIs can analyze the pain signals from your brain, figure out what's causing them, and even help you control the pain. Think of it like a neurofeedback, but for pain. You could consciously turn down the pain levels, or with implanted electrodes, you could have certain areas of the brain stimulated to reduce or even stop the pain. Pain actually rewires the brain by changing how neurons connect, but BCI can help rebuild those pathways, fixing the brain's circuitry. Neurogaming. In neurogaming, players use brain signals instead of controllers or keyboards. You literally use your mind to control characters or trigger a special ability. It's like the future of gaming, where your thoughts are the controller, or imagine entering the metaverse by simply putting on a headset and boom, you are in. The future. A personalized BCI world. The future of BCI is about personalization. From tailored medications to customized therapies, BCI will rocket us forward, and who knows, one day we might merge with AI, or maybe even talk to our pets and understand their language, literally reading their minds. Or imagine connecting human brains together and sharing knowledge instantly. No more losing the genius of scientists like Francis Crick when they pass away. Their knowledge could live on in a database passed on to future generations. BCI will allow you to control everyday tasks, from making toast to driving your car or watering your plants while you are on a vacation, all with a thought, challenge, and ethical concern. But this tech isn't all fun and games. There are real challenges, like noisy signals and the fact that every brain reacts differently to BCIs. It's not a one-size-fits-all. And then there's the ethical stuff, privacy, security, and whether we are messing with human free will. Could people misuse this tech? How do we ensure informed consent? And will this change what it means to be a human? In conclusion, superhumans are ahead. We're just at the start of the amazing journey with BCI, but with the right development and clear rules, it might open the path to a world of superhumans. So, are you ready for the future or not?